All right, so this is part 3 of the endocrine system. And I keep stressing to you, make sure you can label the diagram. Know how to label all those parts, particularly the ones in the brain. Remember, the hypothalamus is sort of the boss of the endocrine system. It connects the endocrine and nervous system. That's pretty important. And it is really important in terms of helping us maintain homeostasis. Just below it is the pituitary. And more toward the posterior, the back side of the brain, you got the pineal gland. Today we're going to focus on everything down lower, the adrenal, the pancreas, and then the reproductive organs. Don't forget about how negative feedback works. Remember that negative feedback is the idea that there's some issue. So you need to release a hormone. Go and pull that noise through. England. Josh, lock the door. Let's just say that your blood sugar is too high. So what hormone needs to be released? Insulin. And what's the gland? It's going to be the target gland. Pancreas. So it's going to be the pancreas. So first of all, the hypothalamus senses there's an issue. It sends out an order, what we call a releasing hormone, that goes to the pituitary, front part of the pituitary. It then sends out orders to the pancreas. In this case, that's called a stimulating hormone. The pancreas starts to make its hormone, in this case insulin. The hypothalamus is monitoring the levels of insulin. So is the pituitary. That's why it's called feedback. When those levels get to a certain level, the hypothalamus says, okay, pancreas is doing its job. I can stop barking at the pituitary. The pituitary, when it notices they get to a certain level, it says, okay, things are okay. I can stop yelling at the pancreas. And when both of those orders cease, what happens to the pancreas? It stops making insulin. That's why it's called negative feedback. Remember, negative feedback's always trying to get you back to where? Quick reminder about the thyroid, right around your throat. Remember, it's a main hormone, thyroid hormone. You might hear it called thyroxine or triiodothyronine. It's about cell respiration, speeding it up. Pretty much every cell, remember, has a receptor for thyroid hormone. Also remember, though, it makes this other hormone called calcitonin, which helps to regulate your blood calcium and blood phosphate levels. I want to focus today, though, on the pancreas, and like I said, the reproductive glands, and maybe a little bit on the adrenal today. Remember that your pancreas is really 2 glands in one. It's endocrine and exocrine. Some of the things that it makes, it sends out through a tube, a duct. Other things, it sends directly to the blood. Most of the pancreas, as we said last time, this was the pancreas. Most of it is made out of cells that are called acinar cells. And those are the exocrine parts. It makes 2 main categories of exocrine kinds of things. What are those? What are the exocrine things that the pancreas makes? Digestive enzymes, which need to end up where? Nope. Small intestine. And what else does it make that needs to end up in the small intestine? Yeah, it makes stuff called the alkaline fluid, or its base. Because the pancreas isn't prepared to handle what? What's the pancreas not ready for? Why does there need to be a base? Because the intestine is not ready for what? Acid coming from the stomach. So it neutralizes that stomach acid. But we're not really too concerned about the exocrine stuff today. We're talking endocrine system. Remember that spread out in that pancreas like little islands are these tissues called the islets of Langerhans. And these are the endocrine parts. Those little dots represent the parts of the pancreas that make hormones. And we've talked over and over again about the two main hormones, glucagon and insulin, and how that glucagon is made by these cells called the alpha cells. And glucagon's job is to raise blood sugar. And it can do that in a couple of ways, but the main way is that it causes cells in places like the liver to break down glycogen and put glucose back into the blood.
What is the alpha cell?
It's just the type of cell that makes glucagon. So it's a type of cell in these little red areas.
Is that important to know?
I would note it. And then insulin is sort of the opposite. What's the word for hormones that have opposite functions? Insulin and glucagon. Yeah, they're antagonists. Insulin, remember, lowers blood sugar. And it can do that in a couple of ways. But the main way that you need to be concerned with is it causes certain cells, especially cells in the liver and the muscles, to take glucose out of the blood and to use it to make glycogen, to store up glycogen. Remember that diabetes, specifically diabetes mellitus, is the most common form of diabetes. It's the kind where you have high blood sugar. It can cause all kinds of weird symptoms. Things like having to urinate all the time, polyuria. Things like being hungry or being thirsty all the time, polydipsia. Being hungry all the time, polyphagia. It can cause pH problems with your body fluids. And it can cause you to go into coma, in addition to things like poor circulation. Diabetes can end up leading to blindness. Can eventually cause amputations because you're not having enough circulation in places like the feet and the legs. The most common type, we talked about it a little bit last time, is type 1. I don't know if it's the most common type, but why is type 1 called type 1? You get it early. And they're not 100% sure what causes it. A lot of people think it's an autoimmune disease. Some think it's caused by some kind of viral infection. But essentially, the parts of your pancreas that make insulin are destroyed, either by your own immune system or by some kind of infection. So this is sometimes called insulin-dependent diabetes. You gotta take insulin shots if you have this.
Can you look for common type 2 diabetes?
From type 2? Yes. Type 2, since Phil brought it up, is most of the time caused by what? Yeah, poor diet, being too heavy, not exercising. A lot of times people who have type 2, they can be treated with medicines other than insulin. And a lot of times if they'll just lose the weight, exercise, change their diet, the symptoms of diabetes essentially go away in a lot of cases. Not always, but in a lot of cases they'll go away. Important that you can explain that diagram. So here's our set point. This is where we want our blood sugar levels to be, blood glucose levels. If we eat something sweet, those levels go up. Pancreas quickly secretes insulin. It causes the livers and the muscles to take that glucose out of the blood and make glycogen. It causes the adipose or fat cells to take glucose in and convert it to fat. That lowers our seesaw back down to where it needs to go. On the other hand, if it's been a while since we ate, blood sugar levels drop, pancreas releases glucagon. Glucagon causes glycogen to be broken down in the liver. It causes the adipose to break down fat. All that releases glucose, bringing our levels back to where we need them to be, our set point. That's all we're going to say about the pancreas today. Let's talk more about the reproductive glands and get into the cycle, reproductive cycle. All right, so the gonads are the ovaries and the testes. The ovaries make two main hormones, estrogen and progesterone. Sometimes you may see estrogen and other components of it called estradiol. Don't let that confuse you. It's just another term for estrogen, essentially. Estrogen does a lot of things for you. It stimulates the maturation of the sex organs. It causes the secondary sex characteristics. The kinds of things that happen to a girl's body at puberty is what we're talking about for secondary sex characteristics. It also helps to regulate the reproductive cycle, the menstrual cycle. It's really important for maintaining a woman's bones. It's also important for maintaining heart health in a woman.
So is that found in like, if you wanted to like over 50?
No, it actually, for a long time, they thought that giving a woman estrogen after menopause would be helpful. It seems like it ought to be, right? But then maybe 10 years ago, what they find was happening to those women that they were giving estrogen to. They were getting all kinds of cancers, they were having heart attacks. They're not really sure what's happening. Still not really sure. But in a lot of cases, they have discontinued estrogen therapy in women past menopause.
But it's good, like it's okay for women who are treating.
It's good while you're making your own one, but when you stop, they're not really sure what's going on there. Progesterone's the other one. We'll talk a lot more about progesterone here in a second, but it's involved in regulating the menstrual cycle and the reproductive cycle. And then the testes make testosterone, cause maturation of the sex organs. Again, the secondary sex characteristics, the things that happen to a guy at puberty, facial hair growth, body hair growth, deepening of the voice, muscle development. They're also important for the sex drive and sperm production. You might see the term androgens thrown around when people are talking about testosterone. Androgens are just another word for male sex hormones. So testosterone is an example of a particular androgen. All right, but the main thing that I want to talk about today, and this is going to be the focus for most of the rest of our time today, are the hormones that control like the menstrual and reproductive cycle. And I think we will start. I think we'll start with this diagram. And probably the first term, and we mentioned this a little bit last time. Let's talk about what this thing is first. Endometrium. What? Yes, the inner lining of the uterus. And like we said, during the cycle, it's going from essentially falling off to getting thicker and thicker and thicker and thicker and thicker. And it just continues to rotate through that cycle of getting thick, sloughing off, getting thick, sloughing off.
And it gets during ovulation, right?
Just after ovulation. Just after. So let's start off by looking at this bottom picture. That's looking at the endometrium. So here's day one of a typical woman's cycle. What starts to happen on day one? That's when the bleeding stuff starts. Because what's happening to the endometrium? It's falling off, literally. There's all kinds of blood vessels in there, so that's why the bleeding happens. And you can see for the first few days of the cycle, it gets thinner and thinner and thinner. But then somewhere around day 7, day 8, somewhere in that neighborhood, it starts to thicken back up until it gets its thickest about day 25, 26 or so of the cycle. So that's what's going on with the endometrium. Let's now go up to the top picture and look up there. Up at the top we have a follicle. A follicle is essentially the egg, and the cells around it. And you notice that it starts off about day 1 really tiny. But as it progresses through the cycle, it starts to swell. And remember, where's this follicle at? Yeah. Where's it located at right now? On the surface of the ovary. And it's swelling up, like I said, sort of like a zit on the surface of the ovary. Right there on the surface. So it's swelling, and it's swelling, and it's swelling. And about day 14, what happens to that swollen zit on your ovary? It pops. and outshoots, in this case, the egg. But what's left behind is also important. So you got the egg that popped out. That's ovulation. But the part of that follicle that's left behind still in the ovaries is called the corpus luteum. And it turns out to be almost as important as the egg because it becomes a hormone-making factory. And in particular, it starts making lots of a hormone called progesterone. And that hormone, if you notice, when the levels of progesterone start to go up, somewhere around ovulation, notice that this pattern looks almost identical to that pattern. Progesterone causes the lining of the endometrium to get thick and to become vascularized. What's vascularized mean? Blood vessels. Grows lots of blood vessels. And that's really important if an egg is going to land in here and implant. That lining has to be thick and vascularized for that to work.
So the only implant gets pregnant when it needs to be fertilized.
Yes. So now let's look through the other hormone levels and kind of talk our way through this. So notice that about day 1 of the cycle, all of the 4 hormones that we're going to talk about, their levels are fairly low at the beginning of the cycle. So the levels of estrogen, the blue line, progesterone, black line, LH, or luteinizing hormone, is the green line, and FSH, follicle stimulating hormone, that's the red line. They start off all pretty low. Estrogen, notice, continues pretty constantly until we get almost to the ovulation period. So about day 10 or so, it starts to go up. It helps this follicle to mature. It peaks out somewhere around day 13 or so. Estrogen levels do. All right, another hormone that we need to go ahead and mention here. Let's go ahead and talk about FSH, the red one. Notice its levels are pretty constant until there's a surge around day 13 or 14. Remember, follicle stimulating hormone makes the follicles get bigger, swell. It makes the gametes mature. So it peaks out right there before ovulation. Where's it coming from? Where's that hormone coming from? FSH. Where's it made? It's one of those, it's one of the tropic hormones. Where do tropic hormones come from? Pituitary. It's a hormone made by the pituitary that's affecting a gland somewhere else. LH, the green line, is also a tropic hormone made by the pituitary, secreted, goes through the blood, controls another gland. Notice that the LH levels stay pretty constant until right before ovulation, and then they peak out, and then they go right back down. LH triggers ovulation. It triggers the actual release of the egg. It's the hormone that triggers ovulation.
What is luteinizing?
Forms the corpus luteum. Yeah. All right, but the one that I want to focus mainly on today is the progesterone. Because remember, once that egg pops out of that follicle, that egg's going to go into what? Fallopian tube. It's going to start heading down, and little cilia in there are going to push it. But what's left behind of that follicle, still in the ovary, corpus luteum, it starts making a surge of progesterone. And that progesterone surge essentially is a signal telling the endometrium to get thicker and more vascularized. No, progesterone. That's what progesterone is. Now, if fertilization doesn't happen, what starts to happen to that corpus luteum about day 26 or 27 of the cycle?
Does it go along with everything else?
It starts to die, starts to degenerate. So as this starts to degenerate, what's going to start to happen to these progesterone levels? They're going to start to drop because the corpus luteum makes them. And as the progesterone levels drop, what starts to happen to the endometrium? It starts to slough off. It starts to fall off. And that's what triggers the cycle to start over. On the other hand, let's say that fertilization does happen. What happens to that corpus luteum if fertilization does happen? It stays there. Which means what happens to the progesterone levels? They pretty much stay constant. Which means what happens to the endometrium? It stays where it's supposed to be. It stays thick. It stays vascularized. And it pretty much just does that. Doesn't fall off. So you got 4 main hormones, all of them really, really crucial to the way this happens. 2 of them, LH and FSH, are coming from the pituitary. 2 of them, estrogen and progesterone, are coming from the ovaries.
Dr. D,
Yes, sir.
why is the body so over-prepared for reproduction?
Over-prepared?
Yeah, because at most hospitals, you can only have like 10 children. So why does the cycle happen like every month and then have somebody start?
Well, I mean, I guess if you think about what we talked about in this class, the purpose of life, according to biologists, is the way. Make sure your genes get passed on, so you're just ensuring that you meet that purpose. That would be the best answer, I think. Yeah. Birth control affects the levels of these different hormones. Progesterone mostly, I think.
Like it causes you to have less progesterone.
And it can cause 2 things to happen. One, it can cause you not to ovulate the way you're supposed to. Some of them do that. And others cause the mucus in the reproductive system to be so thick that sperm can't get there. Yeah.
Is that what they prescribe birth control to women who like have a really tough time in their children?
Yeah, because it can kind of stop the cycle to some extent, or at least slow it down. All right. This kind of just summarizes what I just told you. So we'll just read through it. You don't need to write it down, but like it says here, the follicle cells, the cells around the egg, they release some estrogen. As the follicle gets bigger, the levels of estrogen go up. Estrogen in the beginning causes the endometrium to get a little bit thicker. LH and FSH cause the follicle to eventually mature. And that spike of LH we saw about day 14 causes it to ovulate, to be released. The corpus luteum, stuff that's left from the follicle, left behind in the ovary, starts to make this huge amount of progesterone. And that causes the endometrium to continue to develop, continue to be thick, get ready for implantation. If it doesn't happen, the corpus luteum disintegrates, falls off, and that causes the endometrium to disintegrate and slough off, and that's when menstruation starts. Another thing that we need to mention is this hormone called HCG, human chorionic gonadotropin. This is actually a hormone made by the baby, not by the mom. This is coming from the baby, from the embryo. And its job is to cause the corpus luteum to continue making its hormones. So essentially it's a signal from the baby saying, hey, I'm here. Keep me here, please. Because if the corpus luteum goes away, what else goes away? The baby. The lining of the uterus sloughs off, which means if the baby's there, it sloughs off too. This is the chemical that pregnancy test for. This is how they know if you're pregnant. They're looking for the levels of this particular hormone in your blood or in your urine stream.
Like you would detect it.
They can detect it a lot earlier now than they used to, sometimes within days. Small small levels, but they're constantly getting better and better. All right, just briefly review these two glands, because I'm not going to talk much about them at all. Remember the pineal sort of toward the back part of your brain, sort of the back middle. It makes this hormone called melatonin. Don't confuse that with melanin. Melanin is the protein that determines what? Skin color, hair color, eye color. This is a completely different thing. Melanin helps to influence your sleep-wake cycles. It can sort of act like a biological clock. What term did we use for these? Another term for the sleep-wake cycles? Circadian rhythms. So that's melatonin, which is coming from the pineal gland. Also remember you've got your thymus gland, which is right around your sternum, your breastbone. And that as you get older, it starts to shrivel up and go away. But its job, we've compared it over and over again to a dojo, like a ninja training facility for your immune system. In particular, your T cells, the cytotoxic T cells, the helper T cells. They're called T because they develop in the thymus gland. We've got one more gland we need to talk about, and we'll pretty much be done with the endocrine stuff, and that is the adrenal. And I'll leave this here for a second while people are writing, but where are your adrenal glands at? Right on top of your kidneys. So, your kidneys sit about right here in the lower part of your back. The adrenal glands are just a little dab of tissue right on top of that. And like I said, they're found atop the kidneys. Sometimes they're called suprarenal glands. Supra means what? Above. If you ever see that word renal, R-E-N-A-L, in biology, it means kidney. So above the kidneys. They're the above the kidneys glands, suprarenal. But like a lot of glands, the adrenal gland is really two glands in one. There's the inner part and the outer part. And they make different hormones, different sets of hormones. The medulla is the inner part, the adrenal medulla. That's the inside part of the adrenal gland. And the cortex word is a little misleading because it's cortex. It sounds like it ought to be where? Yeah, but cortex. It sounds like it ought to be at the core, right? It ought to be in the middle. That's where I'm going. It's not. It's the outer part. But if it helps you to remember, the cortex of your brain is the outer part of your brain as well, right? So cortex means outer. The adrenal glands make a lot of hormones. A lot of the adrenal hormones help us deal with stress. Think what main one? Epinephrine, adrenaline. But some of the adrenal hormones also help us to regulate ion levels, even glucose levels to some extent. Even things like swelling can sometimes be moderated by adrenal hormones. All right, so let's start off by talking about the outside part, the cortex of the adrenal. And the adrenal cortex makes a couple of categories of hormones. One category are called the corticosteroids. We'll talk more about those in a minute. And it also makes this category of hormones called the mineralocorticoids. Remember, what's a mineral? Like a metal ion. So the mineralocorticoids are hormones made by the cortex that help us to regulate ion concentrations in our body fluids. And really the only one of those we're going to talk much about is sodium. It's really important for maintaining sodium balance. And the one example of a mineralocorticoid we're going to talk about is this hormone called aldosterone. So that's an example of one of these.
How much stuff you're producing.
Yeah, I mean, I think it's more body size than it is sex. But yes, definitely. Now, aldosterone's job, like we said a second ago, is to maintain sodium balance in your body fluids. Here's the thing, sodium's a solute, right? So where you have more solute, you're also probably going to have more what? More what? Which is going to be what? Water. So more sodium causes you to retain water, right? More sodium in your body causes you to retain water. More water is going to mean more what? We're talking about in your blood vessels, for example. More water is going to mean more pressure. So it can cause blood pressure issues. Aldosterone can be related to blood pressure. Here's the thing. Aldosterone reduces sodium excretion in the urine. It causes you to keep your sodium in your body fluids instead of urinating it out. Maintain sodium. When you're stressed out, you tend to make more aldosterone. So more stress means more aldosterone, which means more sodium in your body fluids, which also means more water in your blood vessels, which means higher blood pressure. Yeah.
Is the adrenal cortex, like, are the adrenal glands affected by trophic hormones?
Yes, and we'll get into some of those in a minute. Why would it make sense that when you're stressed, your blood pressure might go up a little bit? Why might that be a good thing? Yeah, it could get more blood to your organs faster. Right? A little higher pressure might be a good thing in short bursts. But here we're not just talking about like stress due to fear. This could be like work stress or home life stress or any of those kinds of things. And that can lead to long chronic stress, which can cause chronic high blood pressure, which can end up causing things like your heart to swell and die, essentially. It can cause blindness. It can cause all kinds of stuff, high blood pressure.
So stress is like a
So stress can lead to all kinds of issues with your blood pressure. There is a case called aldosteronism, where essentially you're making too much aldosterone, like chronic high levels of aldosterone. And it can cause hypertension, which is a fancy word for what? High blood pressure. It can cause edema. Now that's a word you may not have heard before. Anybody know what edema is? If you watch House and shows like that, you've probably heard edema before. It means swelling. Swelling, because you're retaining sodium and therefore you're retaining, yeah, but more solid means more water. It's because you retain water, swell. And another problem, when you keep sodium in, you tend to urinate out potassium. So it throws off the balance between sodium and potassium if you have too much aldosterone.
You need more potassium than you want.
Well, not necessarily more, but you need potassium too, because the balance between those two is how it works.
Oh, sodium potassium.
Yeah, sodium potassium pump, and therefore what?
Stop respiration.
Not cell respiration. Your nerves. So this can cause all kinds of nervous issues as well, because your balance of sodium and potassium gets all thrown off. But that's aldosterone. That's one example of a mineralocorticoid. Aldosterone causes you to maintain sodium in your body fluids. Therefore, it causes you to keep in more water, and it causes things like blood pressure to go up. We'll mention one more, and then we'll call it a day today. Another group of hormones made from the cortex are the glucocorticoids. And the glucocorticoids They influence metabolism. They can influence blood sugar levels and even blood volume. They're also stress hormones. Just like we talked about with adrenaline, adrenaline can cause your blood sugar levels to go up for a short amount of time, right? So can these. And that's really important if you're going through what? Fight or flight response. You need that sugar for energy and ATP and all those kinds of things. Maybe the most famous glucocorticoid, you might have heard of this one before, is a hormone called cortisol. So cortisol is one of these. And notice what it does. It promotes gluconeogenesis, making new glucose. It causes your body to make its own new glucose. But where you've probably heard of it before is these last things. It may have anti-inflammatory and anti-immune effects. Well, not necessarily in some cases, but it can cause you to, it can reverse swelling to some extent, let's put it that way. It can also lower your immune system. This is a stress hormone. So if you're stressed out, your immune system gets weaker. The inflammatory response is actually part of your immune system, right? So that can be a bad thing.
Doesn't it stop it so you have your energy to take it?
Yeah, I don't know if that's really what it's going on there. It ends up doing that, but if that's why it's doing it, I don't really know. But doctors, because of these anti-inflammatory effects, use cortisol or a lab-made version of it to control swelling. And I'm going to bet that some of you guys, for some reason or other, have probably taken that before, prednisone. That is an anti-inflammatory medicine that's very similar to cortisol. Prescribed all the time to people who are having swelling issues, whether it's after surgery or whatever may be causing swelling. Cortisol can be given to them. Also, these glucocorticoids are sometimes given to people after organ transplants to lower weight, and therefore to lower the chances of rejection.
Is that a hormone or is that just a medicine?
It's essentially an artificial version of cortisol. All right, and then the last thing we'll mention today are some problems with the adrenal gland, particularly the cortex. There's this disease called Cushing's syndrome, or Cushing's disease. It's caused when your body makes too many of these glucocorticoids, too much of it. And notice the symptoms. Hyperglycemia, that would be what? That's hyper, so it's high blood sugar, almost like a diabetes kind of thing. Muscle atrophy. What's atrophy mean?
You don't do something.
Yeah, wasting away. Hypertension, so it can cause high blood pressure. We already talked about edema, swelling. Moon face and buffalo hump. What in the world are we talking about there? I'm not sure why, but this seems to be way more common in women than in men. And I'm going to bet you guys, I know we have a lady, actually two ladies that I go to church with, or have went to church with over the years, so I'm pretty sure had this. They sort of get almost like a hunchback appearance. Looks like there's this big thing growing on their back, essentially. That's the buffalo hump. And then their face gets like wide and flat. Usually older women. But it's a problem with their adrenal glands in a lot of cases, causing them to swell. Can the adrenals be removed? It's just swelling, so, well, I mean, I guess they could, but they're not. They're probably going to try to treat it with some of the hormone. The other one I'm just going to briefly mention because we're about out of time, but the other disease is Addison's disease. This one is probably most famous because John F. Kennedy had it. You know, a lot of women in the day, I mean, if you really get right down to it, John F. Kennedy was only president for a short amount of time, right? He didn't do very much. But he's remembered as this great president. A lot of it is because he was a good-looking dude. The women thought John F. Kennedy was like a rock star. And one of the reasons that people thought he was so good-looking is because he had this disease. Because notice one of the symptoms. It causes increased skin pigmentation. He looked like he had a tan all the time. When in reality, Kennedy was a very sick guy. He had to take injections of adrenal hormones on a regular basis, or he would have died. Because his adrenal cortex was not making enough of its hormones. So he had low blood sodium levels. His blood potassium levels were too high. The low blood pressure?
Yeah.
Well, you'd be less likely to be ill. I mean, your blood's not moving the way it needs to move. And if your potassium levels get too high, what happens? Your heart stops beating. So this is crucial. Low blood glucose. So you're going to feel tired all the time. You have appetite issues, vomit a lot. Said the skin pigmentation. It looks like almost like a copper-colored skin tone. But anyway, we'll talk more about those next time. It's probably a good place to stop for today.